Okay, well, good morning, everybody. This is Identity, Access, and Privacy in the New Hybrid Enterprise. I'm Scott Morrison, CTO of Layer 7 Technologies. And I'm really pleased today to have my good friend Eve Mailer, who's a Principal Analyst of Forrester Research, joining me on this webinar. So we're going to be talking essentially about the new approaches to dealing with identity, the new approaches to dealing with privacy, and the whole problem of access control as it's beginning to evolve in this new enterprise web. It's a fascinating time to actually be, be doing work right now in the kind of new web-based integration. It's very, very exciting. Now, most of you will probably know Eve from the work she's done over the many, many years in SAML, in XML, and now, of course, she's doing tremendous work in the area of OpenID Connect, and in particular in UMA, which is her baby, and she's going to tell us a little about what's going on there. So before we get into it, a couple of quick housekeeping chores. Let me just advance the slide real quickly here. Chat any questions you've got. We'll try to deal with them as we go through near the end. There's a Twitter hashtag for today's event. That's L7Webinar. And of course, you can follow all of us here on Twitter. I'm at K. Morrison. Eve is at XML Girl. And of course, you can both look at our respective companies at Layer 7 and at Forrester as well to follow us there. So without any further ado, I'd like to pass this right over to Eve and let her go with this. And I'll pop in about halfway through. Thanks a lot.
Sounds great. Well, welcome everybody. So today I would like to just talk with you about identity and access and privacy in the new hybrid enterprise. A little bit about myself. At Forrester, I serve security and risk pros. I focus on identity and access management, particularly federated identity management. I like to look at consumer scale populations, taxpayer scale, citizen scale populations when it comes to identity. I also focus on strong authentication and API security. So today I wanted to take a comprehensive view of access control challenges and also emerging technology approaches to solving them in this new world. So one of the things we've become comfortable with in the last decade plus of federated identity management is that SAML is there to help us, the security assertion markup language. But, you know, some folks are saying, sounds awesome, maybe later. We've really had a decade plus of partial success, and I would say a lot of lessons learned in secure distributed computing and federated identity management. But now we're presented with Web 2.0, Web 3.0, 4.0, mobile trends, SaaS applications. We have challenges to our businesses where we are dealing with smaller margins. We have these frenzied competitive landscapes, and we're facing cybercrime. And it turns out that SAML and some of its technological friends are really being strained and not helping us as much as we need help in the emerging in the extended enterprise. So here's how I want to approach today. I want to talk a little bit about the problem space, then introduce a concept that Forrester is promoting called zero trust identity, and talk about some of the emerging solutions that may help you achieve zero trust identity in the API economy, and then share with you a few lessons from an actual organization that's doing it. So without further ado, I wanted to share with you some words of wisdom from a famous, what's become known as the Google engineer rant, which accidentally got exposed on Google Plus to the entire world last fall by Steve Yegge, who's currently a Google engineer, was an Amazon engineer, and he observed some things about Google and Amazon that were interesting. One of the humongous successes that he attributes to Amazon is that they issued a mandate that every single function in the company would be exposed through service interfaces. This was a big, no-holds-barred approach that they mandated, and that is what Steve Yegge attributes their success to in the main. Now, he observed next that there's a problem when you focus on accessibility, meaning access to value-add functionality of the company. Its evil twin is security. And as he notes, boy howdy are the two ever at odds. So he sort of made a counterintuitive point perhaps, which is that if you dial accessibility to 0 and have great security, you actually have no product, which is no good. But it's possible to have pretty much no security and have a successful product, as he points out with a bit of snark, like the PlayStation Network. So, this is a reminder to security pros to, understand our purpose in life and how we have to support the business and become business enablers. So I would submit to you that you don't have to compromise one to get the other. So a lot of times we see these slide decks that look a little bit like what I'm about to present to you about the extended enterprise, which Forrester defines as an enterprise for which a business function is rarely, if ever, a self-contained workflow within the infrastructure confines of the company. So I'm going to try and take it a little farther and talk about the IAM implications of the extended enterprise. The first dimension of challenge we have is that the apps that you use to perform your business functions don't often live with you. They might be in a private cloud, which is a little bit far away from you geographically, perhaps. They might be in a public cloud. They might be SaaS apps run by a company that isn't your company. So that's one dimension of challenge. Another dimension is the way that people access those apps might be through networks or through devices that are unmanaged or that you did not provision those people with. And then the third challenge is, and this is not actually a new challenge, but it's not just employees of the company, identities that you could say you own who have to get access to these things. Increasingly, there's B2B partners, there's members of civil societies that are kind of your customers, there's end user consumer customers, there's all kinds of folks out there who are in populations that you do not directly manage that you have to worry about. So what does this mean for identity and access management? Well, if you're in the unextended enterprise, your problem is as small as that little box there. Good for you. However, that's not the case with most folks today. Most folks need to purposely go beyond the perimeters of their company to do their business. It's not a broken perimeter, it's how you do business. So the extended enterprise is actually not a problem per se, it's a solution to a new, more agile way of doing business. And it actually needs to become part of everybody's core business model. So your identity and access management problem is really this big. And if you think of every point in that cube as a new problem you have to solve, then you really do have a problem. But you do need to have at least an audit trail of accurately authorized access to all those points as long as it has to do with your business functions. Now, lest you think that maybe lightweight social use cases don't need this kind of security, so they don't have to worry about this, I wanted to just point out that Twitter has a wonderful example of how they were not satisfied with the kind of extended enterprise business proposition they have as it was done a few years ago, which was they like to add these the capabilities of third-party sites and apps, native and web apps, connecting to Twitter to do something on your behalf. And here you see my list of Twitter-related apps that I've connected to Twitter to work on my behalf. And so you can see that in order to avoid having those third-party apps collect my username and password to connect with Twitter, they actually mandate now that these third-party apps route me through Twitter to log in and consent to that connection. So Twitter hates password sharing but needs to enable accessibility, and so you could see the implications of Steve Yegi's rant right here. They want accessibility, but they want to up their security, and so they had to innovate. Now, what does this mean inside the enterprise? Well, for example, if you've got a lot of mobile use, even among your employees, then classic window-based authentication options may not be available to you or ideal. If your external apps that you're using, say SaaS apps, have local authentication options, you may want those options to be using strong authentication, but you may not be able to configure them the way you like for the policies around strong authentication within your enterprise. Further, SaaS apps sometimes don't have all the tools they need to make fine-grained access decisions on your behalf the way you would like them to. So these problems are really endemic to doing anything in an internet-enabled fashion. So, okay, is SAML really failing us? Well, okay, failure may be a strong word, but let's take a look at a statistic here. This is actually data from late in 2011, mid-2011, showing the extent of adoption of federation technologies in the enterprise, 1,000 or more employees, and what Forrester considers small to medium businesses, 20 to 999 employees. And what you can see from this is that enterprises are pretty comfortable with federated technologies, and about half of them already do it, a little more than half, whereas SMBs are really just not there. Way more than 50% haven't done anything about it yet. So what I would submit to you that in the main, this is SAML-based identity federation, and in the main, it's really just for large enterprises and governments today. If you think about the choices that you have when you're trying to achieve identity management and access management goals across domain boundaries, your choices really amount to federating, synchronizing in some bulk fashion, and then doing a trick like an LDAP bind or something. And nobody really likes the LDAP bind solution if the partner is very far away from you in terms of trust. And synchronization has problems, but federation clearly has too much friction in it today. And SAML in particular, as we know, is not great for mobile native app use cases. It's not great for offline use cases. And it's not super great for dynamically building federation relationships so that you can onboard lots of partners pretty quickly. So I think that we can summarize this by saying if the goal is one enterprise IDP, identity provider, to many relying parties, RPs, that is to say externalized authentication, then we can say that this traditional approach has enabled this goal a little, but obviously it hasn't reached everybody. Now, if we look at SOA security, service-oriented architecture security, if you look at the most loosely coupled possible mechanism of securing all these messages flowing around, that would be WS security, which is a standard. And we can see that this is the latest data I have, and I don't think it's increased since then based on some things I've been seeing, talking to my colleagues who specialize in enterprise architecture. The use of WS security, it looked like it was sort of going up with a bullet, but it was hanging out at like a third among IT firms that are in the doing SOA. And there are just some operational sticking points for this as well. For starters, it's kind of, if you want to use WS security, it's a great solution for dynamism, but it takes a lot to set up, and mutual SSL is great if you don't mind, if you have just few partners and you can sort of statically configure those. A lot of times what people are using instead of WS security is just something specific to the technology stack they're using, like Java. And that's great, but that requires coding. So clearly we've got sort of a gap here in terms of really internet scale, think Web 2.0-like dynamism in terms of security. So let's take a look at what Zero Trust identity is about. So let me introduce it to you by talking a little bit about network security, which is where this concept came from. And my colleague John Kindervag at Forrester has written a ton about Zero Trust and its model of network security. So if you picture on the back of some network appliance or a firewall, normally you have a plug that says untrusted, goes to the internet, or trusted, goes to the internal, your internal environment. Should you trust the trusted port? The answer is no, you shouldn't trust the trusted port. You can have folks like Bradley Manning on your network. You can have all kinds of folks punch through your firewall. There's a number of problems. So what we need to do is make an assumption that's a very hard assumption to make, but it's a very important assumption to make, which is all traffic is basically threat traffic until proven otherwise. So zero trust means the initial assumption that you make when anyone approaches to ask for access. And so that's what we're going to do for identity. So what can we say are the goals for a zero trust approach to identity? For starters, it has to center on sensitive applications and data. In essence, you need to teach apps in some fashion to protect themselves. Second, you need to unify treatment of access channels, populations, and hosting models. And I'm starting to think of this as B to star. You might have B to B, you might have B to E for employee, you might have B to C for consumer, you might have B to D, which is developer. So the more you can make those the same, the more you simplify, and the more you can apply this difficult assumption to everything. So the third goal that you have to have in trying to achieve zero trust identity is prepare for interactions at internet scale. Just make as if everything is on the network's edge. So with those requirements, let's look at three things you have to do to achieve zero trust identity. The first is you have to plan for both inward and outward identity propagation from your enterprise. And so I think we're pretty comfortable in this era of knowing at least what federated identity is and externalized authentication is. with the notion that, yes, you are an identity provider in your organization, and you might have a staff user store, you might have a customer user store, and in certain circumstances, in order to achieve various business functions, you need to serve as an identity server for those external partners of various kinds or even internal apps that need to perform these functions. So they can serve as consumers of your identity services. But you know, there's another pattern you have to be aware of, and you can't always be an identity provider. Sometimes you've got partners coming in, you've got institutional customers who have many users among them who need to use your business services, and you might have consumers coming in for various reasons. They might be your customers, or it might be for lead gen, or it might be for a number of social media savvy exercises. So this is, two-way flow is just the reality going forward. So one thing to realize is that the function that you need to perform internally to handle both of these flows is to have a security token service, or STS, that handles the issuance, the translation, and the consumption, variously, of various kinds of identity tokens in order for various apps to do their jobs wherever they live. So that's thing number one. Thing number two is you really need to go from identity as a service, which is what we started talking about in the last few years, take the leap to the next step of internet scale and think of IAM as an API. And so here what I'm showing is the open web API facade pattern that we see so often, which is you've got infrastructure, it can scale out, it can be elastic, whatever it is, but it's exposed to the outside world through web service and app APIs. And you can think of those little yellow dots as endpoints. And now you can construct all the apps that need to consume those APIs, make calls to those APIs as clients of those APIs using those endpoints. So what happens when we apply this pattern to the identity and access management world? Well, you start having IAM infrastructure for identification, authentication, maybe identity proofing, authorization, provisioning of accounts, a whole bunch of things. And indeed, you have to see yourself as a cloud service provider of these functions because you're authoritative for those functions. And anyone who needs to use those functions is a client, whether they're internal to your organization or whether they're external. And by the way, you should be a client to others' IAM cloud-based functions where you're not authoritative for those functions. So this is what IAM as an API means. So a couple of notes on this. Obviously, you've got these APIs, and they need to be robustly protected, whether they're for your business functions or whether they're for this kind of meta function of identity and access. We'll talk a little bit about technologies that you can use to robustly protect those interfaces. The second comment I wanted to make has to do with fine-grained authorization. Now, in truth, externalizing authorization from apps is hard, no matter how you slice it. Interestingly, in this new API economy, it's getting a little bit easier only because the API itself determines the grain that you can get at. So what I would submit to you after talking to a whole bunch of folks is that if you want fine-grained access, you have an opportunity to design your API to support that. If you don't care about that so much, you can define your API without that as a consideration. But it's certainly possible to achieve fine-grained authorization if that's what you need. So in preparation for telling you the third thing you have to do for Zero Trust identity, let me just first observe that, great, we have new emerging identity solutions. And I always think of Men in Black, now that Men in Black 3 is out in some theaters now. I always think of, well, now I have to buy the White Album all over again, as Tommy Lee Jones's character said. Well, actually, they do attract. Why do they attract, even though they disrupt and they're backwards incompatible and give us headaches? Well, because, as Douglas Crockford said, the good thing about reinventing the wheel is that you can get around one. And working in the standards world for actually a couple decades now, you know, I've been on both sides of this, working on the new handy thing. Actually, SAML was that new handy thing that was making a lot of Kerberos and PKI experts uncomfortable, and now it's become the old thing, and we have some new things that we need to look at. So that's just the reality. So what are these emerging standards? I think it's fair to say at this point that emerging standards for identity and access management interfaces do have an edge over the traditional ones if you're trying to do Zero Trust. And partly that's because of the past that we've had of SOA and the SOA-friendly standards that have grown up around them. They share some of the same deficits. Not to say they're bad, but these standards that I'm showing here, the MLs for the most part, have solved some problems, but they don't scale all the way to some of the things we need, as I've previously mentioned. So in provisioning, we've had the service provisioning markup language. In authentication and single sign-on, we've had SAML, and SAML is probably the most successful of all of these to date. And then in the realm of authorization and access control, we have WS security, the security mechanism for web services. And then we also have XACML, the extensible access control markup language. And I would say they've achieved a middling level of success if what you're going for is blanketing every possible service out there. If what you want to do is blanket every possible service out there, we don't have anything that's done that yet, but we have some contenders that are going for the privilege. One is called Simple Cloud Identity Management for provisioning. And I'm not going to spend a lot of time in this presentation to review it, but you can go to simplecloud.info to learn more. Another is OpenID Connect, which is a modern relative of OpenID that's giving SAML actually a run for its money, and I'll talk about that a little bit. And then finally, we have the most important substrate, OAuth technology, and I want to mention a little bit about user-managed access, or UMA. All of these things on this bottom line here are getting a lot of notice and attention, including by vendors generally. So why are these technologies attractive? What makes the emerging technologies have so much juice? Well, because security professionals tend to lose control in the new API economy. In the past, we've had IT security architects who deal with line of business developers who come to the IT security folks and ask for permission to do something or ask for some kind of configuration of systems so they can deploy successfully internally. So they would come with a question. The security guys famously are the department of no. Sometimes I know they say yes, but this dynamic is changing. And the way it's changing is that when you publish an API, even if it's for your internal app developers, you're distancing yourself on purpose. That's part of Zero Trust identity, is accepting that everything might be equally far away from you, even if the app that connects next, the client that connects next to your single sign-on API is, written by the guy, one cube over from you, rather than by somebody around the world who doesn't work for the same company. So in doing that and taking the interface approach, you're distancing yourself. And indeed, if you publish an API for open use by people who aren't in your company, maybe by folks who are just on the open web who want to become developers of client apps, like Twitter has done, like LinkedIn has done, like Facebook has done, and like a whole bunch of businesses with SaaS apps and APIs have done, then in fact, those developers who are connecting to your stuff, they're kind of your customers. And in an important way, they're often your channel partners. So, you can't make them do stuff. It all depends on the value of the API that you're presenting to them, and it's much more of a negotiation. So by virtue of regularizing the security function that you're putting on top of your API, you're minimizing the friction of doing security against the value of your API, the value add, whatever you're trying to monetize or get value out of. So regularizing is good. That makes what you're offering predictable. Standardizing makes whatever effort those developers put into securing their API calls reusable. And then simplifying just reduces friction in general and actually makes things more secure. So think of it like recycling: reduce, reuse, recycle. So let's take a look at these emerging technologies. I got infamous for creating Venn diagrams for identity standards. So I've got a new Venn of access control to perpetrate on you. Here's the new Venn of access control at a very high level with not too much detail in it. So here you see three technologies that are interacting in really interesting ways. OAuth 2.0 it's really a centerpiece of the new emerging technologies. And OAuth 2.0, the way you can think of it, the elevator pitch for it, is that it's a way of enabling constrained delegated authorization of access to APIs. The elevator pitch for OpenID Connect is simply that it's an OAuth-protected single sign-on API. And finally, user-managed access can be described as an OAuth-based method for doing true claims-based access control of the sort that we might be familiar with in the enterprise context, only for everybody, including people on the internet. Now, they actually do kind of refer to each other. OpenID Connect is based on OAuth, and you could even say that it's 90% OAuth. So they share some features because of that. UMA leverages both OpenID Connect, precisely for doing claims-based access, and OAuth. So you could say that it's probably about 60% OAuth. So these things are obviously sharing features with each other. And that's a feature of the new API economy. I said I wasn't going to talk about SCIM much, but I'll just point out that SCIM is another OAuth-protected API in essence. So let's take a look at what the magic is in all these three elements. OAuth's magic is to let a person delegate constrained access from one app to another. Now, a lot of times in the past what we've done is let a person enable an app to impersonate them in talking to another app by stuffing their primary credentials, typically a username and password, into that app somehow so that it can make an API call. This is not very secure. Instead, what OAuth does is arranges for that person, as you saw with the YFrog case, to log in at the primary, at the server side, and consent to sharing of an access token with the client side so that it can make calls that represent both it and the user to the server side. This access token is often known as a valet key because it enables access in a scoped manner. That is to say, maybe not everything the user can do is actually what YFrog can do. This has a lot of benefits, in particular for the ecosystem overall, but if you look at what it enables the client app to do, it's very interesting. It enables client apps to get out of the business of storing passwords at all. It allows for a variety of user authentication methods and user devices, and this is because OAuth came of age in an era where we had these things really quite commonly. You can track and revoke access on a per-client basis. Because of the scoping mechanism, this constraining mechanism, it allows for least privilege access to API features, which is a zero-trust tenet. And as a bonus, it solves for a much larger class of needs around security, identity, access, and privacy. For example, you can capture explicit user authorization, as we saw on the YFrog screen. Now a little bit about OpenID Connect's magic. It turns single sign-on into an identity API of the sort that we get familiar with, talking about open web RESTful APIs, that's simply OAuth-protected. For those of you who are familiar with OpenID 2.0, by the way, OpenID Connect takes the name of OpenID, but it's mostly OAuth. So I would say it takes the branding of OpenID, but not the technology substrate. So it is, in fact, backwards incompatible to that degree. So let's do a little bit of comparison. If you look at SAML 2.0 and OpenID traditional 2.0 single sign-on, they do standardize how you initiate a user's login session. That's their function in life. They don't say anything about collecting users' consent to share their attributes at login time. SAML does have an option to have high security identity tokens with its SAML assertions. What does OAuth solve? Well, it's not responsible for initiating a user's login session. It doesn't care what API it's protecting. It is responsible for collecting a user's consent. And it doesn't, all by itself, say anything about identity tokens that are interestingly high security. OpenID Connect swoops in by sort of combining all the best lessons learned of SAML and OpenID as was, and literally basing itself on OAuth, and manages to get a trifecta here and hit all three pieces of functionality: users login, collecting user consent, and using a new piece called JSON Web Tokens, pronounced JOT. It can even solve high security identity tokens. Now, that's not all. OpenID Connect also solves for distributed and aggregated claims coming from multiple attribute authorities, which is something SAML itself didn't really solve, although a number of efforts trying to build on top of SAML tried to solve, like the Liberty Alliance Identity Web Services framework. But that was pretty heavy, and I would put that in the SOA-friendly row. And then finally, one thing that's being worked on heavily is how to deal with session timeout. And this is something that SAML for a long time never really had. A number of people have put effort into solving it, but it was considered out of scope for SAML, and it's not considered out of scope for OpenID Connect, so that's pretty important. A little bit more about OpenID Connect. What is a killer app for OpenID Connect that could help convey the importance, in particular, of the distributed claims? Street Identity is the nickname of a project that Google and a number of others are taking part in to inform the NIST program this is the U.S. Program for National Strategy for Trusted Identities in Cyberspace, or NSTIC. So imagine that you've got an app on the web. It wants to be a relying party. To function, it needs your verified street address so that it can perform this function that it's advertising here on the screen. So you've got a service provider, which we'll call an SP, needs some trusted data about you. Well, there is an attribute provider that you use that happens to have that data. But you use, let's say, Google as your identity provider to log in. You use it as an authentication service. And it doesn't have this data, but it's able to broker your permission to provide that data from an attribute provider. So here's the really interesting part. What if the attribute provider, some little valuable piece of data, like your verified street address, which normally costs a stamp and several days to confirm, what if it can demand a fee from the service provider that wants to know that piece of data? And you can permission the sharing of that information as well. That's pretty darn powerful. That's what a new identity economy looks like, where you're part of the process and where privacy turns into a proposition of you get to selectively share information and be part of the process. Now, what happens if you apply the same pattern to any little valuable piece of data, particularly volatile ones, credit scores, verified email addresses, identity-proofed identities? These are things that are valuable, and we can see economies around them arising through these new technologies. So what does this all mean? It means that OpenID Connect is going to lower the price and the complexity bar for all kinds of federated sourcing of identity information. We already see a few enterprises, forward-thinking enterprises, not just being SAML IDPs, but also becoming OpenID Connect IDPs. And I think this is significant. And we see key cloud service providers already using APIs that are similar to this, who are willing to sort of sync up in the fullness of time as OpenID Connect finishes its interop testing and its approval phases, which is soon. So what that means is anyone who's smaller or has less money, or even emerging economies around the world, can start to get into the federation game more easily. And SAML-based solutions are going to see price pressure over time. I'm already talking to a couple of vendors who are trying to specialize in OpenID Connect. Now let's talk about user-managed access. So its magic is turning sharing of online access of whatever with arbitrary parties in the world into an OAuth-derived solution that you could say has privacy by design. With OAuth, we see a consent pattern being primary. With UMA, it applies OAuth to enable, I've got Alice to Alice here, so OAuth is typically Alice to Alice sharing. She's on both sides. She's operating both apps in question, Twitter and YFrog, for example. What if Alice wants to share her calendar with Bob, or her tax records with her accountant, or her health records with selected family members? The means we have for this today are not only not very secure, not very standardized, but she can't get a global view of how she's shared things. So what UMA does is basically apply a claims-based mechanism for her to write a policy whenever she likes, saying, only Bob at Gmail can see this particular resource. And then when Bob shows up, he does have to be around when he wants to get access. She can go off and be asleep or, heaven forbid, be in an emergency room, whatever it is. Bob can approach and ask for access and be asked to prove that he's Bob at Gmail. You can have policies for basically anything, but this simple example shows that you can treat this as claims-based authorization with arbitrary parties. And because Alice is using a centralized authorization manager to write the policies, she can share policies no matter where all of the stuff online that she uses lives. A little bit more about UMA. There's 3 killer apps that I wanted to talk about. First of all, going back to street identity. Well, if you're actually sharing with various apps that you like to use, your verified street address, your credit score, whatever it might be, what if you wanted to centralize management of what you're sharing on a street identity basis? This is the next logical step because it's going to get awfully unwieldy and unscalable to the whole internet to manage these things on a pairwise app basis. And so here you can see in federated identity, we call this the identity provider, the attribute provider, and the relying party, and these UMA roles double as these street identity roles and OpenID Connect roles. Secondly, well, what if access management in the enterprise needs to be API-ified? What if what you're accessing is SaaS APIs? What you may very well want to do is control and audit access of all of your employees to your SaaS apps. And so these roles would come to the fore. This language comes from access control terminology, particularly XACML terminology. UMA's authorization manager is a policy decision point. Every host would be a policy enforcement point, and the requester would also be a requester. Finally, another killer app would be zero trust enabled privacy for business to consumer business opportunities. And so this is a real example that I've heard of where people have interest in doing this, which is a telco, and telco companies have a lot of data that they know about you, not previously amenable to your controlling access. They would like to enable you to control access to things like your location data. What if they could also be your hub for sharing health data later on? That's data they don't own, but it's data that might live elsewhere, and they can be a centralized place where you might want to control sharing. And so here you can see the OAuth labels for the UMA parties, authorization server, resource server, and client. So UMA actually has a role to play in all of these. So I wanted to talk about an example of a real-world company that is that's doing some of this, actually, that's doing what I would call zero trust identity. And the lesson, the overall lesson to be learned is, if you're in IT, what you want to do is brandish carrots instead of sticks for all those who need to interact securely with systems that you're protecting. Sticks make people run away, carrots attract them. So this one research organization has an experience with making these interfaces and making apps use those interfaces, become clients of those interfaces. And so here are their objectives. One is unify all the authentication and authorization flows for all of their protected resources, whether they live on the premises, off the premises, wherever. Another objective is to serve internal and external users alike. So, for example, they're experimenting with a business social collaboration platform that external partners, along with internal employees and contractors, can use. They want to remove friction and risk in getting all new internal apps that are being created to use externalized authentication. A lot of existing apps, I mean, it's an organization with a lot of engineers, as many organizations out there are, and so their goal is to simply ensure that new internal apps have a greater incentive to federate than to create their own user management and authentication flows. They want to enable brokered distributed attribute provisioning. This is the street identity use case, because they see themselves as authoritative for some pieces of information, but not all. Finally, enable use of their systems by people that they deal with, partners who have pre-identity proofed high-quality credentials. So, for example, if you look at the U.S. government, there's a number of circumstances in which they require employees and contractors to have credentials just like this with smart cards. So what if these systems could enable those to be used when those partners get into these systems? What was their approach? Well, they have a SAML IDP. They're putting an IDP proxy beyond that to speak. Right now, OpenID, and starting, I believe, next month, OpenID Connect. I just mentioned that. They're taking a really interesting approach to how they onboard different relying parties. They're letting their users, their employee users, take responsibility for choosing to use any apps that already accept OpenIDs. So they can use their employee OpenID at an external app as long as that app wasn't already blacklisted. And if it was already whitelisted, well, then that already works. So they have this gray list, what they call a gray list approach. Very fascinating. And finally, the developers of the system were not in IT, but they partnered with IT from the beginning. And the rationale that seems to work in these conversations is, look, enabling ad hoc login creation, user management, and authentication in each new app is worse, because now if somebody wants to use an app that's external but can't reuse their employee OpenID, they're probably going to be reusing passwords that were used in the internal context and so on. So this is the architecture they chose, and here you can see that the corporate SSO is where the SAML-based functionality already exists. The internal OP is the OpenID provider, which is an IDP proxy that leverages the existing identity provider. And then for anybody who has to create a local login to use internal apps and doesn't have their own OpenID, they can use this external OP, OpenID provider, to come in. So there's apps on both sides that are being used, and there's means of consuming and creating identities actually on both sides of the corporate firewall. What were the results? Well, I'll share with you some positives and some negatives/next steps. The positives: new internal apps seem to federate by default, even if they're long-tail apps. What do I mean by long-tail apps? They might have a dozen users and be very low-touch, be used only every few months. But if they use the corporate-based single sign-on through OpenID, they're better off than if they had created user management and authentication functionality. Secondly, the IT folks get a level of comfort because they're operating the production quality servers themselves, so they were brought into the process. Third, these dynamic associations with external apps, these gray-listed apps, are auditable, so you can trace choices back to users. The kind of decisions they're making, frankly, around these decisions to connect with certain apps is kind of like the decision to give your email address or your phone number out to somebody that you want to do business with. It's very similar. What are the things that haven't worked so well yet? Well, this organization definitely prefers OAuth-based technology, and you can see why. It enables you to have a simplified, unified basis. But OpenID 2.0 turns out to have become legacy, especially among developer apps out there, particularly around the Stack Exchange and related websites that do Q&A management. Secondly, there aren't enough external SaaS providers yet who are enabling inbound single sign-on at all. A lot of them are still doing proprietary patterns. I think this is something that's going to change over time, so they're going to just continue to work on that over time. So what lessons can you draw? Briefly, low-usage internal apps aren't necessarily low-sensitivity apps. They might be protecting data that are very high sensitivity, even if they've got a dozen users who only touch the app once a year. So you want to apply zero trust identity principles and be data-centric and try and reduce the friction around federating so as to reduce the risk. Secondly, for extranet apps and APIs, you want to think lightweight in your solutions because you've got partners who might be a lot smaller than you and might have very unsophisticated or practically non-existent IT. So great, large enterprises, we know they probably are IDPs, great, but small companies, maybe not so much. Finally, expect protocol discussions to reflect the power relationships with your partners. If SaaS providers don't have enough incentive yet to accept inbound single sign-on, I'm not sure what you do to convince them yet. I think once they see that enough companies are prepared to single sign-on in, that helps their decision-making process. One last word. I always say, when it comes to rich versus reach, technology that is rich versus technology that has reach, go for reach. Internet scale is everything, and working with as many parties as possible is hugely, hugely valuable. So with that, I will thank you for your time and attention and turn it over to Scott.
Thank you, Eve. And listen, I think that last point you just made about rich versus reach is particularly, I think, important these days because we've seen so many technologies come out over the years that have spent a lot of time trying to work out the breadth and the corner cases and everything like that. And I think, if anything, characterizes kind of this new movement of integration, of which, you know, the three of OAuth, OpenID Connect, and UMA, I think really represent this new idea of identity integration using lightweight protocols. I think they really are about web scale. They really are about that greater reach that's so important right now. So what I want to do is kind of follow on exactly what you've said and look at some real-world solutions that we're actually deploying at Layer 7 today for actually trying to provide exactly this kind of wide-reaching solution. Now, if I had to characterize really what the old enterprise was about, I kind of look at the relationships as being very formal. I mean, if you think about it, what we tried to do when we did integration with the outside world was we, reached out to actually create a relationship with our road warriors, and we created VPNs from, their devices into the enterprise. And it was a very point-based solution. It was a highly managed solution. Same thing with, like, when you think about it with browser clients. We build websites and work under a very constrained model there. And then anytime we had formalized relationships with trading partners and that, there tended to be a lot of ceremony behind it. If I had a supplier or something like that, it was a big deal to integrate with them. Usually, you would have architects sitting down, kind of working out the big picture of everything, on whiteboards, and forms would be, filled out in triplicate, defining what the relationships were about. But there's a lot of effort and ceremony behind it. What I think is really interesting now in this, what we're calling here at Layer 7 the new hybrid enterprise, but what I know Forrester is thinking about as the extended enterprise, is that the relationships are different. They're much more fast-moving. They're much more informal, really. We're working with mobile devices, which don't like the big heavyweight protocols of the past. They just don't tend to work very well there. We're integrating with things like cloud applications that, again, are very, very quick moving, very agile in their deployment and that, and tending to move towards the kind of protocols like RESTful styles that I think really try to bring things together without a lot of ceremony, without a lot of heavyweight infrastructure getting in your way. And we're also getting into more informal relationships with developers where rather than the enterprise trying to own both sides of a conversation, they're sort of recognizing that they're really fundamentally about being the server side. They're fundamentally about managing the applications on the server side and making that as available as possible to a wide range of different clients, users, developers, etc. So the power dynamic is very different. Really they're an enabler now as opposed to a group that's actually trying to impose its will on both sides of communications. And that's actually really important. And I think the thing that ties the whole thing together is really this new movement towards APIs, which is really in a lot of ways a recognition that when we built the web, we really did something right. We built the most scalable system in the history of humanity. New systems can appear, new websites can appear. Nobody has to register that in any central place. It just happens and the whole web keeps going. That's actually something that's really, really interesting. And so a lot of what the whole API movement is about is recognizing that when we got the web right, we really got it right and should apply those same kinds of principles to more sophisticated interactions than just browser to server interactions, which, when you think about it, are really a human to computer interaction. We should be using the same kinds of protocols, the same kinds of ideas that were embodied in, the original web architecture, and using those for more sophisticated applications that really are computer to computer, machine to machine, device to device. And that's really a lot of what this API movement is about. It's about taking the principles of RESTful architecture, bringing that in with more, I would say, simpler ways of rendering information using JSON specifically instead of XML, and then bringing these new identity standards and emerging approaches to dealing with identity and single sign-on and federation, and bringing all that to bear. It's all very, very consistent. It's much more grassroots. It's much more really driven by massive reach, as Eve eloquently pointed out earlier on. So here's a really simple example, if it's still being a little cloudy. Something as simple as the basic get, to a URL, defined really as a query onto a particular piece of information. In this case, I'm using the URL right here to actually define a hierarchy and a service or an API all the way down to staff members and a particular staff member, Scott. So if I threw that into my web browser, okay, if I just put that into the address bar of my web browser, I might get something that looks like this, which is a JSON data structure, which actually renders all of the information, the attributes and things like that about me, about Scott. And this, in fact, is my address right there. That's the power, really, of the whole API movement, the idea that literally your web browser can become your IDE. It's as simple as that. You don't have to go out and buy a whole bunch of, expensive IDEs and things like that. You don't have to spend time with, big and complex registries and repositories and difficult libraries to deal with any, with simple communications. You can just get it done using what's there now. It's a very profound idea. But if we stop for a moment and think about what I just did, there's a few shortcomings. And the first and most obvious one is we didn't authenticate it all. That information was wide open. Now, in this case, it doesn't really matter that much. I mean, this is a webinar between friends now, so I don't mind too much if you've got my phone number here and my, my address at the office. In fact, I'd probably be more than happy to give it out to you, with my business card. But there's other times when, of course, that's not the case. There's other times where really I would rather make sure that this API had some level of authentication on it. And furthermore, probably some level of authorization as well. I don't want to give access to everybody. And furthermore, I may actually want to decide who's going to get access to what. And this, of course, is the UMA equation that Eve has been talking about. Like, what if I, want to do something besides accessing my own information? What if I want to make it available to Bob or Alice? How can I authorize that? So not just Scott to Scott, but Scott authorizing access to his attributes to Bob or Alice for one reason or another. And that's really why all of this is coming together. All of these, three important pieces, OAuth, OpenID Connect, and UMA, to really solve that fundamental problem in the context of this new agile approach to doing integration on the web. So why Zero Trust? And I think Eve gave us some excellent examples about what Zero Trust is about. And I tend to sort of characterize it as you really can't trust anything out there. You have to assume that appearances are deceiving, just as in this picture where we've got Canada's finest actually, arresting a Santa Claus. And it turns out that there's actually an interesting internet meme about Santa's being arrested. I could take my pick of many, many different pictures of different Santa Clauses being arrested. But, truth be told, I mean, the thing that really underlies this whole picture and what's really, really important is the fact that really we have to assume that every transaction is untrusted until proven otherwise. And it's incumbent upon that transaction to prove that it is what it says it is. And really, OAuth is going to be the basis of really doing that in the future. So if I look at the best response to this whole thing, it could actually be really characterized by I think a fairly simple modification of the old, World War II slogan from in the UK, which was, keep calm and carry on, but maybe modified a little bit to be keep calm and just trust no one. And maybe even make that a little more obvious and say keep calm and we should be really using OAuth, OpenID Connect, and UMA. Because the truth is, even though these standards are evolving on a daily basis, they are beginning to solidify enough that we can start to take advantage of these today in our applications, and in fact should be. So that's what I want to really talk about right now and show you some real examples of what we can do today using technology that in fact is available today. So first of all, we'll talk very specifically about OAuth, which is really about how to get access to that API, how you can actually get authorized and authenticated access to a particular API. And then OpenID Connect is how we can share that information, those attributes and things like that, which are very important in some areas where you might be doing things like attribute-based authentication. And then finally, UMA, we'll bring in, which is empowering the user. It's a delegation out to the user to actually be able to decide how their information is being used. And that actually really sets the tone for a lot of, these new technologies, because they are actually about delegation. They are about scaling, not through trying to build bigger and bigger and bigger LDAPs and put more and more and more people in the identity group trying to centralize, the management of all of this, but instead to scale by actually putting the responsibility out into the hands of the people who own the information. And that's a very, very profound inversion, really, in how we're starting to do this, this new approach to identity. So the number one priority that you should be thinking about right now is OAuth, because OAuth is ready for prime time. People are using it every single day. If you've authorized Twitter to actually get access to any other website, or let's say you're on Facebook and you've authorized Twitter to actually allow Facebook to publish tweets up on your wall or something like that, you have, even though you may not know it, used OAuth And in fact, OAuth really came out of the social networking world to solve problems like this, to solve problems about sharing information between multiple accounts on different web apps. So it's not this theoretical thing that, people have said, oh, maybe somebody will have this problem in the future. It actually grew out of a real need where developers sat down and said, this is actually hard to do, and we don't have a good way of doing this yet. So let's come up with a fairly standardized approach there. And I think that's very important. It is a grassroots movement where the more formalized standardization has followed to kind of crisp up the definitions so we can truly get interoperability. And I think that in a lot of ways characterizes the best kinds of standards that we've ever done in the whole industry. So your big priorities for OAuth really are, first of all, to make it very easy, and number two, to make it scale. And let me give you an example of how to make it really easy. At Layer 7, we have a product that we call the Secure Span Gateways. And in fact, we have a particular line called the API Proxy, which is very, very much geared towards managing the security and manageability of APIs. And quite literally, you can just drop these into your network in front of your APIs, and they handle all aspects of security, threat detection, access control, audit, pretty much anything you can think of, about that area. And what we've done is we've been able to split up our capabilities so that any one of our gateways can act, either as an authorization server, which is a very, very important part of the whole equation in OAuth, and integrate with any kinds of identity systems you've got in the background, which is, could be Active Directory, it could be a generic LDAP, or it could be an IAM system like, Tivoli Access Manager, something like that. We've got connectors into all of those, and what we do is put an OAuth layer on top of that. So the whole OAuth exchange suddenly becomes very, very simple to implement. So how simple, you may ask? This simple. So what I'm showing you here is an example of our policy manager. This is where we actually define access control into different services. What I want you to focus on is the piece on the right side that says protected resource on the tab. So imagine that's your API. In this case, it could be an API to get access to this thing called my resource. Okay, maybe it's a query into a database or something like that. What the gateway is doing with this policy, as we call this, is it's just saying any query coming in here, I'm just going to automatically route into the internal network. So what I've defined here is a very simple reverse proxy. Absolutely no authentication, authorization, anything like that. I'm just letting the data flow right through. It doesn't matter who it's coming from or whatever. But what I may want to do is actually force people to actually do an OAuth exchange. Now, if I have to code that up, it's fairly complicated. You have to get a bunch of libraries to do it. There's tremendous interoperability problems kicking around. So what we wanted to do at Layer 7 was make this trivially easy. So this is how easy. What we do is we go in here, we drag down to this component right here which says require OAuth 2 token. We drag and drop it into our, into our policy, and boom, all of a sudden we've got a policy which says any query coming into that API, first and foremost, has to go through the OAuth dance, and it's all handled automatically by the gateways. So the gateways will automatically redirect to your authorization server, which could be, again, in your same location, which will then integrate in with your LDAP directories or your Active Directory or what have you. So very seamless, very, very simple to manage. So the other half of it is how to make OAuth scale effectively, because a lot of the homebrewed implementations that we see out there on the web right now, they may work in a very, very simple restricted environment, but they can't really handle web scale as you get hundreds of services, as you get tens of thousands of transactions a second in a large web farm. We're really good at dealing with this kind of thing with our secure span gateways. So again, we can scale the gateways up, deal with differential scaling between, the authorization server, which doesn't get hit nearly as hard as, let's say, access to a very, very popular API. I mean, imagine access to something like the Twitter API, how many times a second it's getting hit. So you need to be able to scale up, those enforcement points. Eve was talking earlier about the policy enforcement points. That's these gateways. You stack them up as high as you need and deal with the scalability across them right there. And so this solution right there can truly handle, massive, massive web scale. And furthermore, we've also been able to break out the components, as you can see here, to break out token stores so that the actual tokens do not reside in the DMZ. And for a lot of high assurance environments, that's actually incredibly important. We didn't invent this. Our customers came to us who are doing, very, very important mission-critical APIs, and they said this is how we want to architect our systems. And so we broke apart the components, so either they can all reside in, one single gateway, or they can actually be teased out between multiple gateways, where things like the token store actually reside in the secure zone. So if for some reason your DMZ falls, the tokens, the critically important access tokens, are still protected. And so this is the logical architecture that we've actually come up with. And this, again, you just drop it in and it just works. It deals with the scaling. It deals with these high assurance, highly secure environments and makes it as simple as possible. The next piece of the whole puzzle, and I would call it priority number 2, because usually this is the second phase that people start to deal with, is how we effectively introduce OpenID Connect. And this is something that at Layer 7 we're also introducing, where because we have connectors into all of the different directories and things like that, we can actually get access to all of the information about users, whether it's your phone numbers or what floor you work on, or any of that critical information that's actually available, and then render that appropriately through the OpenID Connect protocol. This is an important piece of the whole equation. This is what in SAML you'd use attribute assertions for, and certainly in some areas like the military, for instance, where they make tremendous use of attribute-based access control, things like name, rank, serial number, and pay grade and stuff like that, as a means of the whole kind of access control stew, as they're making that decision about is somebody allowed access to a particular resource or not. This is a new way of doing this, and it actually is highly scalable and, moreover, highly, highly agile, so you can begin to get all of these components out. So with that, the big summary that I want to leave you with, and this is, the kind of prescriptive directory that of actions, is do OAuth now. Don't try to roll your own. It's the old security mantra. Yes, there are libraries out there, but we're finding many of them don't scale, many of them don't interoperate. So instead, use a solution that can drop in and deal with the whole gamut of security, because it isn't only about access control. It's also about threat detection and integration with audits and, being able to close up and version APIs and that. So plan for failure there and plan, moreover, for scale. Also, begin to look at OpenID Connect. You're going to need this soon. I guarantee it. It is an important part of the equation, just as you should be looking at UMA. The work that's being done with the UMA group these days is incredibly important. And Eve, of course, if you know her well, is actually the chair of the UMA working group. And actually, we're taking her away from some of her responsibilities today as we broadcast this webinar, and she's good enough to give us the time anyway. But keep an eye on it, because as she showed you, it is a critically important piece of what I like to think of as the three-legged stool of identity. If any of those legs is missing, you got yourself a wobbly stool. So consider all of these pieces and how they're going to play in your own, new modern hybrid enterprise. So with that, later on we'll be taking some questions and things like that. So I'd like to thank again Eve Mailer for joining me on this webinar, and I'd like to thank you all for your attention as well.
It's been a pleasure speaking with you all today.